Hi everyone. In this video, I wanted to quickly go over some basic function operations. Okay, hopefully this won't take too long. This is a fairly simple topic. Again, it can look intimidating, but it really isn't too bad. Okay, so today we're going to be talking about the sum, the product, the difference, and the quotient of functions. Okay, the sum and the product and the difference of functions typically goes exactly how you would expect it to go. So let me go through a couple of these examples, and hopefully you'll agree with me on this. So if we're going to let h of x equal x plus 3, g of x equal x minus 6, and we're going to let p of x equal x squared minus 9. Let's see if we can find um, h plus g of x. Okay, so if we have h plus g of x, this is the same thing as h of x plus g of x. Okay, so we have h of x plus g of x. In this case, we're going to have h of x is x plus 3 plus g of x, which is x minus 6. Okay, so this is going to be the same thing as x plus 3 plus x minus 6. Let's see, remove those parentheses. Or we have 2x plus 3 minus 6, or just minus 3. So h plus g of x is 2x minus 3. Okay, and this will be true for any functions that you're given, no matter how complicated they get. If you have two functions added together, it's going to look like this. Okay. Similarly, if we have h minus g of x, okay, this is going to be h of x minus g of x. Okay. And sometimes you're asked to evaluate. Let's actually do that for this one. Sometimes you're asked to evaluate a specific number. Okay, so let's try h minus g of 2. Okay, I think on your homework you're going to be given that. So instead of g of x, it's the same kind of thing. This is going to be the same thing as h of 2 minus g of 2. Okay, and you could have done the same thing in the previous example as well. It's the same exact structure. Okay, so if we have looks like we'll have x, or I guess in this case it'll be 2 plus 3 minus 2 minus 6. This will be 2 plus 3 is 5 minus a negative 4, or we get 9. Or you can do this backwards. You could do this by doing uh, h of x minus g of x. Okay, and you would get uh, x plus 3 minus x minus 6. And once we distribute that negative, we'll get x plus 3 minus x plus 6, or we would get 9. Okay, so there we go. That is how this is going to uh, to work. All right. Product is very similar. So if we have h times g of x, and let's use one of our other functions actually. We said p of x was x squared minus 9. Let's do that. H times p of x. This is going to be exactly the same as what we had up here. It's the same as h of x times p of x, which is going to be x plus 3 times x squared minus 9. All right, so here, if we FOIL this, we'll get x to the third minus 9x plus 3x squared minus 27. Or combining like terms, I guess not combining like terms, I guess rearranging it. We don't really have any like terms here. But we can rearrange it in descending order. We get x to the third plus 3x squared minus 9x minus 27. Okay? And you can evaluate that for any points that are in the domain. And speaking of domain, if you wanted to take if you wanted to take the quotient of two functions, let's do um, let's do h divided by g of x. Okay, so when you're doing the quotient of two functions, it's very important that you consider the domain of the resulting function. So this is going to be the same as h of x divided by g of x. Okay, but now because you're going to end up with a variable in the denominator potentially. You have to consider what the domain of the new function is. Okay, so if you look at our initial functions, we're given h of x is x plus 3 and g of x is x minus 6. You could plug any number in for h of x or g of x, and it would make sense for each of these, okay? But this is no longer true for combining these two functions. So now we have h of x over g of x, which is going to be x plus 3 over x minus 6, okay? So again, you have all real numbers for the domain for h of x and all real numbers for the domain of g of x, but that's no longer true now because g of x is in the denominator, okay? And this is your answer, but you do have to note that the new domain is going to be all real numbers minus 6, okay? Because if you plugged in 6 in the this function, you're going to end up with 0 in the denominator, and that's not going to be good. Okay, or we can write this as negative infinity to 6 union with 6 to infinity, where we don't include the 0.6. Either of these are fine, but you should, if you're doing the quotient of two functions, you should always write the new domain if it's going to apply.